Hi, this is Mr. West, and today we're doing a worksheet tutorial on prime factors. This, of course, is from mathdrills.com. There'll be a link in the description below. They have tons of great resources, and I have a playlist for their worksheets. So before we begin, we need to understand what we're looking for here. We're looking for the factors of these numbers, okay? And specifically, we're going to be looking for the prime factors, so we probably should understand what are the prime numbers that we're looking for. So prime numbers, these are all numbers that only have one and itself as a factor. For example, with 2, you can only do 2 times 1. There's no other whole numbers that you can multiply to get 2 other than 2 and 1. So all these numbers, 3 in itself, 5 in itself, those are all prime numbers. So what we're going to do here is we're going to use some strategies to find the prime factorization of these composite numbers. Let's go ahead and start with the first one, which is 18. What I like to do with these is I like to always start with this little trunk here, or the roots, whatever you want to call it. And I always like to put my prime numbers on the left. Okay, so I like to divide by a prime number to start every time. And I'm going to show you what I mean by that in just a second. So sometimes you could do, for example, you could do, well, this is a bad example because all my factors are going to have 1 prime. But let me go ahead and kind of demonstrate what I'm talking about. So trying to decide on the color here. What I like to do is if it's even, which this is an even number, I always like to divide by 2. And like I said, I like to put my prime numbers on the left. So my left side I have 2, and then I know 9 goes on the other side. This, of course, is not a prime number. Okay, it can be further broken down into more prime numbers. So I'm going to think of a prime factor of 9, and it's 3, and it happens to be 3 and 3. Now, what I like to do when I'm done with that is I like to circle all my prime numbers. So I have 2, 3, and 3. I'm not going to circle the 9, okay? That's not a prime number. This shows me these are all my factors that I can multiply to get 18. So I can multiply 2 times 3 times 3. So that would be my prime factorization. I know if I multiply 2 times 3 times 3, I am going to get 18. And now I have all the prime components of that number, okay? And I'm going to show you more examples. Whoops, my eraser's a little too big. I'm going to show you more examples of how we can use prime factorization and why it helps to have all the prime numbers on the left side, okay? Now, that's not the only way to do it. I personally like it. It's just a preference thing because I think it keeps you a little bit more organized. All right, so let's do another one here. This time we have 28, so I'm going to make my little trunk here. It's an even number. I'm going to put 2 on the left every time. Okay, so I have 2 in 14. Now I know 2 is my prime number, but 14 is not. 14 is another even number, so I know I can divide it by 2. And I like to just, as long as you have even numbers, divide by 2. And then I get 7. Now, let's say I don't remember if 7 is a prime number. I can always check, and it is. 7 is prime, so I can go back up here, and I can circle this also. Now I can write this as 2 times 2 times 7. Okay, those were all my, let me make my highlighter a little bit smaller. 2 times 2 times 7, these are all my prime numbers because I circled them. They're at like the bottom of the roots. So 2 times 2 times 7. If I do 2 times 2, that's 4 times 7. 4 times 7 is 28. I can also write this as exponents. If this overcomplicates for you, don't worry about it for now. But I can write this as 2 to the second power because I have 2 times itself twice. So I can do 2 to the second power times 7 equals 28. Let's go on to the next one. So we have 34. Again, you can divide by 2. This one's a little bit more difficult, but this is going to be 17. Okay, so 2 times 17 equals 34. And now I need to think, is there anything I can multiply by to get 17? I stopped at 13 here. Okay, so we might need to come up with a few more actually. So we got 13. Okay, 15 is not. From here on out, the only even number is 2. Okay, that's the lone even prime number. All the rest are odd. So we can check 15, no. 17, 17 is also prime, as well as 19. 21, no. 23, yes. Okay, and there's a few more under 30, but I just need 17. Both these are prime. So this one's actually a pretty small tree. We have 2 and 17, so we can do 2 times 17. Or if you want to use the X, I'm a big fan of the dot. Less writing and it doesn't complicate for a variable. So we have 2 and 17. Let's highlight it. Look at that. All right, there we go. Let's do a few more. So this is a good example of one you can do two ways, and I'm talking about why I like my strategy more. Obviously, I like my strategy. If I didn't like my strategy, why am I using it? But you can do 6 and 8 here. Okay, now this is the reason why I don't like doing 6 and 8 is because it comes down to 3, 2. Then we have, let's say you put 4, 2 here. Okay, 2, 2. The reason why I don't like this is sometimes it's hard to locate your prime numbers because it's a little bit more cluttered. Okay, so what I like to do is, again, I like to keep my prime numbers on the left side. So let me show you what that looks like instead. So I can divide by 2, okay, because it's 48. It's an even number. And now I know it's 24. Guess what? 24 is an even number. I can divide that by 2, and that gives me 6. I know this is an even number. I can divide by 2, and that gives me 3. So there I go. Now I have, did I do that right? 2, 24, 2. No, I didn't do it right. I missed a number. 2 and 12. Hopefully you caught it before I did. And then 2 and 3. Something didn't seem right, and I'm glad I found it. Okay, so then we're going to circle all our prime numbers here and see how this is like, we got all our prime numbers going down the left side until we get to the bottom. I think that makes it a little bit more organized, and this way you're not going to forget any of your primes. So I have 2 times 2 times 2 times 2 times 3. We could rewrite this a little bit more simply as 2 to the 4th times 3. Again, if you're confused on the exponents, I have exponent videos too, but it's not drastically important for this exercise. The prime numbers are what's important, but 2 to the 4th power times 3 is a simpler way we can write it. Now, do you always have to divide by 2? You don't always have to divide by 2. For example, 36, we can divide by 3, and that's 12. Okay, 3 is a prime number. I always just recommend dividing by 2 if it's even because it's easy to remember. But yeah, we can do 12 times 3 is 36. And then we can divide this by 3 again, actually, and get 4, and then 2, 2. So it looks a little bit different. Okay, just as a quick side note, if I were to divide by 2, I would get this factor tree. And see how I get the same number? So I got 3 and 3, 2 and 2. Here I got 2 and 2, 3 and 3. I got the same numbers either way. So that is just something to note. You don't have to do it divided by 2 each time. You can do it different ways, okay? So again, we can rewrite it now. 36 equals 3 times itself twice times 2 times itself twice, or 3 times 3 times 2 times 2. All right, let's see if we can do one more. I don't think there's any that are that complicated. You should be good to go. This one's 2 and 2 in case you're wondering. There's a freebie. And then you just have 3 more to do on your own. But if you have any other questions, leave a comment on this video. I can help you out. You can also leave a comment on any other math drills exercise that you need help with. And I look forward to seeing you next time right here on West Explains Best.